Okay, so the first step we do is take the derivative using the product rule and the chain rule. So f prime of x equals the first term derivative, bring the 5 out front, leave the inside the same, bring the exponent down by 1, and then we have to multiply since we're taking the derivative. Chain rule says we have to take the derivative of the inside part, so times 20x to the 4th.
Oh, yeah.
Okay. And then back to the product rule. Product rule says take the derivative of the first piece. Where's my pointer? The first piece here, derivative is here, and then times the regular second piece. So I'm just going to write that part down. And then we add to that, back to the product rule again, regular first piece, and then the derivative of the second piece. Okay, so regular first piece, and derivative of the second piece, I'm going to bring my 2 out front. Inside stays the same. Brought the power down by 1, so now it's just a 1 power. I don't have to write that. And then derivative of the inside, negative 15x squared. Okay, made it. Okay, now I'm going to put some pieces together. So take a look and see if you can see what pieces in each part go together. I see a 5 and a 20x to the 4th that I can multiply together and put out front. And in the second part, I see a 2 and a negative 15x squared that I can put together and put out front. Okay, so I'm going to do that to make it look a little tiny bit simpler. So my 5 times my 20x to the 4th is 100x to the 4th. And then I just have my other two factors, my 4x to the 5th plus 3 factor and my negative 5x blah 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 factor. So I'll write those in.
Hold on, I don't see where you have the 4x to the 5th plus 3 to the multiple 5th. Where'd that come from?
You mean all to the 4th?
No, the first thing after the plus sign.
Oh, hold on. I'll wait until we get there. So in the second part, this second part right here, the product rule says leave the first part alone, take the derivative of the second part. So the first part alone is this. Okay. And now that I have the derivative, I'm going to take that 2 times the negative 15x squared. So actually, I don't know if I have an eraser. Well, we'll just put plus a negative. So it's plus a negative 30x squared. And then times the other two pieces, the 4x to the 5th piece and the negative x to the 3rd piece. Okay. So now comes the difficult part. Okay, so the next step is to factor out anything that is in common, kind of undoing the distributive property. Do you guys remember this? Maybe? Light bulb, awesome. Okay, so looking at the first pieces as 100x to the 4th and 30x squared, what do they have in common? 10x squared. Good. Anything that can be divided into both numbers, 10 is divisible, 100 is divisible by 10, 30 is divisible by 10. Nothing bigger goes in evenly. And then, and then the x to the fourth and x squared, basically the smallest power can come out front. Okay. So, out front I can take 10x squared. Okay. What else can I take out front? Well, yeah, so I have this term and this term that is in common. However, how many of them do we have in common? 4. Okay. Okay. So now looking at the negative 5x cubed terms, how many of them can we take out front?
1.
Just 1. Okay. So we have negative 5x cubed minus 1. That's all the stuff that we took out front. Now we have to write what we have left. So we took a 10x squared out of 100x to the fourth. What's left? 10x squared. Okay. We took 4 of this term out of here. What do we have left? 1, or, yeah, just none of them are left. We're multiplying by 1. We took 1 of this factor out of here. What do we have left? 1 of them. Okay. Okay. And then we have plus a negative something, so I'll just put minus. I'm right here now. I'll turn that into a minus. So we took 10x squared out of 30x squared. So it's just 3. I made that an extra big minus. And then we took 4 of this term out.
One of those bad boys.
We have one of those bad boys left. And we took 1 of these out of here. What do we have left?
1.
Just the number 1, or, yeah, basically it goes away. Okay, it's not simpler yet, but we know the distributive property because I know that you have taken algebra. And the distributive property just goes like that, boom, and right here, boom, and then you will have like terms to combine. Okay, so the whole front stays the same. This whole front part is going to stay the same. This back part is going to get simplified. So I'm not going to write this for a sec. I'm just going to let it hang out. I'm just going to work on simplifying this for a minute. So I have negative 50x to the what power? 5. We add those exponents. And then I have 10x squared times negative 1, so minus 10x squared. Then I have negative 3 times 4x to the 5th. Negative 12x to the 5th. Negative 3 times positive 3. Minus 9. And I can combine these x to the 5th terms, and then I will be as simple as I can be. Okay. So my final answer, 10x squared, 4x to the 5th plus 3 to the 4th, negative 5x cubed minus 1. How many x to the 5th do I have? Negative 62. X to the 5th minus 10x squared minus 9. Now, this is a fine final answer, but I am actually going to take it one step further because I noticed something.
We're going to distribute the 10.
I am not going to distribute the 10. I want to leave it as factored, either as multiplied out as possible or as factored as possible. And this is as factored as possible. However, I noticed something interesting going on with the negatives here and here. And I am going right here. Oh, I'm not showing that? Oh, my little pointer doesn't work up there. So right here and right here. I see that I have all negatives. Okay, I'm going to divide those two terms, each by -1. Factor out a -1. What's going to happen? Dang it. Pop. So if I factor out a -1 from here and a -1 from here, those terms will be positives and positives. And I would have a -1 times a -1 out front, which is just a +1 out front. So really, my final answer is this. Yeah.
So if there's 3, would it stay negative?
Yep.
Then if it's 4.
Yes. Yep, even odd powers apply here, or even odd rules apply. So either of those are acceptable answers. But this is probably the one you would see in a multiple choice question.